So here we got a potential map. We're going to do our part 2, which is to draw the equipotential lines and draw the electric field lines and then calculate the magnitude of the electric field. So first step is to connect the dots with the same potential with smooth curves. So I have the two poles, 10 volts and 0 volts already drawn. So I'm going to connect the 9 volts now. And then the 5 volts. Well, they don't have to be perfect. The next step is to draw the electric field lines. One thing that is very important is the electric field lines, they are perpendicular to the equipotential lines. So I'm going to draw like from these points of my terminal. Okay, so relatively equally spaced. So the first one is this one, perpendicular is easy. And this one is also very easy. The 4. So now to draw the lines in the middle, just make sure you're keeping them perpendicular, so they have to bend a bit. All the cross must have 90 degrees. So here, and the direction of the electric field lines are from high to low. So here we have 10 volts in the middle, so they're all pointing outwards. Our equation we use is E electric field, the magnitude of the electric field is delta V over delta S, S being the perpendicular distance. Say you want to calculate the electric field of this point, say point A. Now, the closest 2 points we have that we know the potential are here and there. Here it is 5 volts on the pink and 1 volt on the orange line. So all I have to do is to take a ruler and measure their distance. Distance is 2.1. So I can write 2.1 centimeters here. So now I can calculate delta V. Because it's a magnitude, I'm going to take the bigger number, subtracting the smaller number. And you calculate, use your calculator. You got 1.9 volt per centimeter. If the potential lines are very close together, like in this situation, we want to calculate the electric field at point B, where all the potential lines are squeezed together. You can also choose points that are further, not the nearest. If the electric potential lines are very, very close together, like in this situation, you want to find the average electric field at point B. you can choose potentials over a few potential lines. For example, here you can measure the distance between these 2 points, the one on the 10 volts and the one on 0 volts, because they're too close together. So you measure that from, I'm going to blow this up, from this point on the 10 volts and this point on the 0 volts, the distance is, you measure it on your paper. So the distance is 0.2 millimeters, 0.2 centimeters. So then the electric field here would be E, that one is A, EB is delta V over delta S, which is, so here from is, I measured it to be 0.2 centimeters. That is 10 volts minus 0 over 0.2 centimeters. That equals to 50 volts per centimeter. So the electric field at point B is much higher than the electric field at point A, and you can see that because the equal potential lines at point B are a lot more denser than at point A.